I think we've probably all heard the story of the death of the internal combustion engines. I've actually heard this a few times in my career. It's been, I think, uh, failed in that successful application and will continue to be a critical portion of what the technology solution is going forward for many different sectors, right? Um, it's not going to take over global mobility, heavy duty trucking, off-road industry, maritime, but it's also, going to remain a significant contribution in the light duty vehicles. We've seen some swings there recently, and now a swing back to, the need for internal combustion engines, whether they're in a standalone application or in hybrids. And we're seeing a need from all of our partners. We work very closely with both the light duty vehicle manufacturers, commercial vehicle manufacturers, OEMs, tier ones, right? And they've reached out to us and say, hey, you need to still provide graduates with this type of experience now as much as ever, and maybe now more than recently, because they have a real need to continue to have this type of employees. And so that's why we're really standing up this graduate certificate. We've taught courses in this continuously. I've taught IC engines since I've joined here 22 years ago, both undergraduate and graduate. So it's building upon an established, really an established curriculum. And we're bringing in some established curriculum that Andrea is bringing in from another source. So it's really a combination of a couple different programs. So I think we all understand that IC engines aren't going to be here. There's a large need for this in all industries, both mobility, power generation, and others. And so this is really in response to that need from our clients, who are both the students and industry. Next slide, please. Okay, so I'm just going to talk a little bit about the department. So I'm in the mechanical and aerospace engineering department. Michigan Tech is all about STEM with a big E in engineering. The mechanical and aerospace engineering department is the largest department at the university, well known, especially in this industry, to provide both undergraduate and graduate students with the experience to move in and really, be able to do the job on day one. That's really what Michigan Tech's known for. Again, all of the industry recruits from Michigan Tech, and we partnership with all of those industries in research and training and other activities. We have a number of programs that we've developed with industry partners, GM, Ford, and others, specific to help them meet their needs. And this is just another example of that collaboration. This includes, online work. We've been doing online education for, I think, myself since I started 20 years ago. So it's not a new experience for us to be working with online students that are, full-time employees. So we understand what that market is and how to successfully develop course material for that, for the online students that are now employed and looking for kind of just upskilling their needs. Next slide, please. So this credential is, again, designed with input from many of our industrial partners through a long established relationships that both myself and Andrea have. Again, it was developed and built for industry from working professionals, understanding what is really needed in the industry. Again, we work closely on the research side. I was previously worked in Detroit for 10 years and still have a number of collaborations with partners there. Have people on our team, including people like Rick Davis, who's recently retired from GM, who's their technical fellow in SI Engines, that's on our program there. And I'll let Andrea speak, but a lot of input from US Car and Andrea's experience. I'll let her talk about these couple next points if she wants to say something.
Oh, sure. So I'm Andrea Strzelik. I was a professor for about 15 years before I joined US Car, United States Council for Automotive Research. we are a competitive research entity of Detroit 3. And so I have a lot of background in, teaching at various levels. And then specifically also, like Jeff, like Rick, I'm an SAE fellow, recognized for my work in fuel effects and after treatment. So this program does have some history developed other places for working professionals. But when there was an opportunity to bring this to Michigan Tech, it was, fantastic to work with Jeff and Rick and a lot of other really fantastic folks there. So, this program and this structure was really designed with working professionals in mind. A lot of the comments I get from students, and I see some former students of another program online, so happy to see them, is that, a lot of what we would talk about would be something directly relevant to them at work the next day. So this is, one of the things about a very applied and technically specific program is that, you can turn around and use this the next.
Thank you, Andrea. So again, many of us that were really all of us that are on the teaching team have a long background as acknowledged by being SAE fellows and others, but have worked directly with a number of industry partners, again, in research and development activities. So we really bring, I think, industry depth and knowledge depth in this field. And we understand what the current challenges are in industry, performance emissions. I worked a long time in diagnostics, in really where the evolving roles are for internal combustion engines for both hybrid applications on and off road and power generation. Next slide, please. Again, my name is Jeff Neighbor. I'm a professor in mechanical and aerospace engineering. I've been working in this space for a long time. I spent 10 years in industry working in the Detroit area with mostly the light duty vehicle manufacturers, doing everything from diagnostics development to calibration development for them. And a lot of experience in both spark ignited and diesel engines. Did some work for a while at Sandia that's pretty well known for combustion and diesel injection. Andrea kind of explained what her background is, but if you have anything else there to add.
I worked at two U.S. national labs, Oak Ridge National Lab and Pacific Northwest National Lab, as long as we're going to toss that in there, Jeff.
Yeah. So not with us today is Scott Mears, but he's an associate professor, is really recognized for his education, has run several awards for his educational capabilities, and works on small engines, two-stroke engines, and is now developing a portable emission systems for CARB and some other companies to commercialize that. Rick Davis is joining us today, but he's on the road, so I won't ask him to talk. So, he's got 20 or more years at GM as a combustion specialist, retired, and then about 5 years ago, he joined the Michigan Tech team, Apps Labs, which is our research labs, but is very much connected with where we have. His specialty is in SI combustion engines, fuels, ignition, knock, efficiency, all things associated with spark ignition engines. Next slide. So I just wanted to talk to you about how we do this delivery for online students. Again, I've been doing this for well over 15 years, developing content and delivering to both hybrid for online and on-campus students. A 3-credit course is going to have 3 50-minute class sections. Our semesters are 14 weeks long. There is a break in each one of those semesters, so you get a little bit of break, you breathe the room to catch up or find some time. And then there's a 1-week final exam period. Not every class. For instance, my class, I have a final project, not a final exam period. All the material is recorded. You can join synchronously via web meeting, but it's also available asynchronously. We use Panopto and Canvas as our tools, so this allows you to, there's a snapshot here, but I can zoom into the slides, I can zoom into the video portion of it. There's I can go forward and backward, so it's a very flexible tool to kind of interact with the content that we've recorded. All the assignments, all the discussions, and all the exams are done electronically through this learning management system, Blackboard. So it's all available electronically. To ensure that we're engaged with the online students, we hold a 1 hour discussion period, recognizing that this everybody's working during the day. We work to find the best time that fits the most of the students. That's in typically in the early evening. It's done with a web meeting, and then can address questions and discuss things that are occurring in the class. I I have some pretty challenging homework questions I give or assignments, and what I love to do is this to discuss with the students. Hey, I can't figure out this problem. I'm more than happy to walk through the problem and help you solve it online, but like to really engage with students in trying to understand. Hey, what are we trying to get to here? So really like that engagement with the students. Next slide. An additional benefit, if you're a Michigan Tech student, you get a number of resources that come through it. We have a digital library, so this includes textbooks and many journal publications, including the SAE technical journal publications, and many journals are available through this. The textbook that we use is the Internal Combustion Engine Fundamentals by Haywood. This is available electronically at no cost to students. So, and there's several other textbooks that relate to this. So all of this material is part of what you get as part of the enrollment. And then we have a significant extensive software suite that we use for these. We use GT Suite in the engine courses as one of the primary tools we use for in the coursework as part of the assignments, and it's part of our final project. So that's available to the students. MATLAB with nearly every toolbox that's available, and I just listed the if you go into the available tools, I think I didn't even get through the A's or the first part of the A's. Right, there's pages and pages of additional software that's available for you while you're a student. So there's just an extensive amount of resources that become available to you as an MTU student, whether it's in this program or any other programs that can help you also in your professional development. But again, all of these tools are provided as part of your enrollment. There's no extra cost for textbook or needing to have GT Suite or any of the tools. You can use these as a student.
So Jeff, as we transition into the overview of the certificate, we did have one question come in. Have you found startups in the automotive industry have found great partnership collaborations through your program? So I think they're kind of asking about the networking side of the program.
Do you mind if I start on this one, Jeff?
Sure, yeah, no problem.
Thanks. I can say, in a previous incarnation of this program, I have seen some incredible relationships develop between students. So I have seen a few startups, but what I can tell you is students often form, homework groups to work together on, or, project groups. And I think some of the networking that occurs in classes in this program has just really shown an incredible amount of relationship building, for people who are very spread out location wise. I've had students work in Japan, working with students in California, working with students in Michigan on projects. And so I would say the LinkedIn networks and all that of these students connecting to instructors and then also connecting to one another is huge. So that's what I want to. Oh, and I see actually Mary, former student, probably wants to also make a comment on that. Can we let that happen, Jeff? Is that okay?
It's good with me.
All right, go ahead, Mary.
So I actually graduated with from the Masters of Engineering and Engine Systems program, which was kind of the previous iteration of this program. And I was a little unique. I waited 13 years between my undergrad and pursuing my master's. And in that 13 years, I was solely oil and gas. And I worked on large natural gas engines and compressors, and quite honestly, still do that to this day. I manage the engineering group for a utility, and still we're commissioning 2 brand new engine packages on June 8th that I have been fortunate to be a part of the design of. But I still talk to, I graduated 3 years ago. I still talk to my cohort members. We became very dependent, and we were all in different industries. So some automotive, one specifically did crankshaft machining and just wanted a degree to back it up. One was worked on motorcycles, and it pushed me to different limits because I've only ever worked on large equipment. And so it pushed me to design a 2-stroke motorcycle engine. And it pushed me out of my limits, and I could not have done it without my cohort. And we really do still keep in touch to this day.
Okay.
Well, that was great, Mary. Thank you.
Yeah.
I don't think I have much to add to that, so that's great. Thank you for the question, and Mary, thank you for the follow-up.
Andrew, thank you for the question too. I think the answer is yes. They gave you very detailed information. So well, I guess we'll move on into the overview of the certificate.
So the certificate is 9 credits. There's 2 required courses, the thermodynamics for engine systems that Andrea teaches and advanced internal combustion engines that I typically teach. There's a number of electives you can take, and there's listed in below that allow you a lot of flexibility in these courses. It would be easily completable in 1 year. We have courses, the primary course here will be in the fall semester. For us, that's a late August start. You can register for it now, so that's why we're here talking about this today. And then the second required course is offered in the spring, which means starts in January for us. Again, each one is about 16 weeks long, with 14 weeks of classwork, 1 week of break, and then the final exam period. Again, there's a number of electives that allow you flexibility to take some seminars, and I'll even talk about some laboratory cases that you can take. And these are fully accredited graduate courses and stackable to a master's in mechanical engineering. So, if it's required that, through your reimbursement that you end up needing to get an MS degree, these are all fully accredited graduate courses. They're the same courses that we teach to our on-campus students, so it's a fully accredited master's program that this can evolve to. So again, I can't really explain all the different fields. I think Mary explained some of those, but really what you're working on, whether it's component level work in air systems, fuel injection, fuel delivery systems, or your combustion system development, or you're in controls and calibration, emissions, after treatment, design, instrumentation, and testing. We actually have a specific course on instrumentation and testing. We'll walk you through modeling methods and simulation methods, and then really systems level integration work. All of these are, well within the fields of study that I think would assist you in your studies, and many others, as Mary highlighted, right? So I think really working to ensure that we can match the content with what real world needs are. And I survey at the beginning of my class and try to understand, hey, is there something specific? I have lots of different content I can put in my class, and try to tailor my class to that specific student set. Maybe I'll take some of these questions at the end of it. Thank you. Just keep posting these questions on the specifics. I think I'll wait to answer some of these questions at the end of it that are specific to the program. So I'll let Andrea, so this is the course that she teaches. You can give you a little bit of overview of the thermodynamics for engine systems.
Yeah, I'm a big fan of all things thermodynamics. So this course, and engines are kind of the perfect thermodynamic system to really talk about. So in this course, it's a firm foundation in thermodynamics and kind of simple chemical reactions prior to, deep diving into some of the more applied courses. So you're going to learn about like thermodynamic properties, including equations of states, first and second law, especially focused on reacting systems. You're going to learn how to perform these calculations as applied to combustion. And then, what we do is by the end of the class, we build up to do a full first and second law analysis of an engine system. And you really can see where, all of the fuel energy comes in and, where our losses are, what things we could work on are, and, where we can still improve efficiency further. And you'll definitely walk away knowing that internal combustion engines are not limited by Carnot efficiency. So, which is like the thing I find myself saying most on LinkedIn. But anyway, thanks, Jeff.
All right, very good, thanks. And so then, I teach the Advanced Internal Combustion Engine Systems. It's a graduate level course. We would require that the student have an introduction to internal combustion engine course, or if you potentially had a second course in applied thermodynamics that covered cycles, we just want to make sure you're well prepared for this course. Again, we focus on what current technology there is and what's advancing in this field, trying to understand both the theory, but also analysis and modeling skills. So I will use data from experimental testing we're doing. We will use models that were developed for production engines in the simulation environment. And then we'll also look to you to apply that knowledge in a final project to apply to an engine technology of your interest. But I'm going to ask you that you have data for that, and I'll point you in direction to have some data for that and be developing a calibrated model, and the outcome of that is, again, the final project. I'm looking for you that we spend the first part of the course, we focus on boosting and turbocharging. It's not something that's typically covered in the undergraduate course, so we make sure you understand that, as that's an important technology in nearly all engines today. And then really want, a key portion of what a combustion engineer will do is to understand what value there is and what information and the challenges with making cylinder pressure measurements and turning that into actionable, understandable, quantitative data on heat release, COV of IMEP, other factors, and so that you understand, the data, limitations of the data, and complexities of the data in doing that work. And again, we will apply 1D engine simulation to both gasoline and diesel engines for both boosting combustion, but we'll dig into a little bit about what some of the submodels are and some of the limitations of those submodels, so you understand, is it predictive, how predictive it is, what kind of data would I need to calibrate this model, and what are the limitations of that model. Again, you would need an undergraduate course in IC engines or a second semester course in thermodynamics, and I would work with all the students to make sure that you're prepared for this. Also, if you've taken the Andrea's course, you will be well prepared for this course in our spring semester. So a great start would be Andrea's course. Not that they have to, they can be done in reverse order. You could take the advanced engine course and then the thermodynamics course, so they could be taken in either order. And then there's just a number of electives. So compressible flow is an important technology. We have 4 lab classes. Now, why am I talking about lab classes for online students? These lab classes are a bit unique. They're actually developed to be able for online students to participate. We do that by condensing the lab in a 1-week period. So if you can get 1 week off and join us in beautiful Houghton Hancock typically in June, beautiful time to be up there.
Better than January.
No, it's not better than January. It's just different than January. There's just a different set of activities you'd be doing in January than June. So weather's beautiful in January. I won't talk about, March may be a little bit challenging. April might be a little bit challenging, but January is beautiful for another reason. So, but if you can spare a week, you can get 2 credits with some preliminary work and follow-up work by attending 8-hour lab classes during that week. So it's an opportunity to get some hands-on work. We have an advanced powertrain instrumentation class, ability to apply some independent study, and then several different seminars that are in this. So again, opportunities to look at several different options in completing the additional 3 credits. So it's 3 credits for the thermodynamics of engine systems, 3 credits for the advanced internal combustion, and then a composite of 3 credits from these courses. Next slide. Okay.
The transition over to Amanda here, the things that you can bring to Amanda and she can help you through those kind of things. But with that, I'm going to go Amanda. You're up next.
Thanks, Jacques. So next steps would be, applying to the program and getting through the admissions process. But I think one of the first things to consider before applying is, do you have time in your schedule? Are you ready for the time commitment of graduate studies? So just want to touch on that for a minute here and say that, you could expect to dedicate somewhere between, 9 and 12 hours a week per 3 credit hour course. So if you sign up to take just one class in the upcoming fall semester, the upcoming spring semester, you're going to want to make sure you have, roughly 10 hours a week to dedicate to that class. You're going to be allocating time toward lectures, whether you're going to join synchronously or you're going to do it asynchronously. You're going to need time to review those lectures and the readings and the assignments each week. And there's definitely a high level of self-discipline that has to happen with our online courses. And so, especially in that asynchronous format, to keep yourself on schedule. And so a lot of the times I get a question that says, are these classes self-paced? Or if you can do it asynchronously, it's kind of self-paced. And kind of like to shy away from that because it's not at your own pace. You still have deadlines and timelines that you have to work within. You're still being given guidance by your instructor. There's discussion time that happens. I think that was each week if I listened correctly earlier. So you still need to manage your time really, really well within each week so that you can stay on task and you don't get behind. It'd be really important too to look ahead as you're working through your classes and plan for additional time when there's major projects that are coming up. And, regular engagement with your instructors so that you don't fall behind. So we're pretty realistic around here. We know that folks that are attending online have other obligations, that you might be working full-time plus hours. You might have a family, extracurriculars. I'm running kids to sports events after work today. So we get that. We know that there's other things in the schedule. And so just having that communication, that open line of communication with your instructors when things come up or things that you need to plan for. There's a big project at work that you need to work around. Can you work ahead in some of your studies or in some of your projects? And they're usually pretty flexible with making a plan that makes sense for you.
I think your instructors here, I know people are working professionals and I think they will work with you, if you have a travel commitment with work or anything. But, we only get to meet with you live kind of once per week, right? So, you have your lectures and all that you're doing. So, missing that or getting behind on some of that stuff can really add up fast. There's only 15 weeks in a semester. So, my recommendation is to try to front end load your weekly classwork if you can.
Sorry, I heard you say my name and I clicked the X button instead of the mute button.
No. Yeah, Mary, I was just gonna say, do you have any advice for preparing, or how to organize your time for these kind of style of classes?
Sure. So I want to be totally upfront. I married, have a child, a husband is in the military, active. My life is about as chaotic as they come. I love internal combustion engines. Now, I all of my experience and history was in the oil and gas industry. So when I started this program in my late 30s, I loved the content and I felt like I could understand the content. But where I struggled is I was learning new programs for the first time. I was learning how to model turbochargers and how to perform calculations in a program called Ease. And to me, that cohort was so like one, again, late 30s. I had a 21-year-old in my cohort. I had a 30-year-old in my cohort. We all came with different levels of experience in our career. So where I could help them understand, like, hey, this is what it's going to look like in the end. I've experienced this, right? They were the ones that could help me. Okay, well, this is how we work through it in the modeling and in the program. And so they taught me that portion while I was able to teach them just some of the more real world experience. I saved so much time creating a solid cohort that I can't even begin to explain it.
Awesome. Thank you guys for that. I appreciate it. Getting into the details here. So if you're looking to apply to the program, there are a few requirements that you have to meet. Applicants do have to have an accredited bachelor's degree in a related engineering field, preferably with coursework in thermodynamics and fluid dynamics. Andrea, I don't know if you wanted to add anything here about the prereq type coursework.
I mean, if you don't have an undergraduate in engineering, like a mechanical engineering or an engineering where you had thermodynamics and fluids, we can work with you. You're not automatically out. We've had students be successful with an engineering technology degree and all that. It just usually means we need to do a little bit of work on the front end before you can come into the program. But like I said, they've been able to be very successful. We just need to get you the equivalent, and you'll be good to go.
Thank you. Admitted applicants typically have an undergrad GPA of 3.0 or higher on a 4-point scale. So we're wanting to review and see that you've been successful in your undergrad studies when we are deciding on admission into the program. There is no GRE required or GMAT or any entrance exams to apply to the program. The application is free for you, no application fee. And really, with the certificate program, we try to make this as straightforward as possible. And all you're going to have to do is provide some transcripts and a resume for that application, and that'll go to review with the department here for them to make an admission decision. So pretty straightforward on those admission requirements. Upcoming start dates we want to mention here. There's definitely still time to apply for the upcoming fall semester. Our fall semester begins on August 31st. We talked a little bit earlier about kind of the sequence of courses and what's being planned for this. And so that thermodynamics class is going to be offered this fall. And then the spring semester is also a potential start option. There was a little bit of advice I think Jeff gave about, might be a little easier if you started with the thermo class before the advanced internal combustion course, but you could start in a spring semester if you wanted to. Applications are available for both of those terms. I would suggest there's not an official cutoff deadline. We're technically rolling admission and we'll continue to review and admit students as they apply. But if you wanted to give yourself a little bit of cushion, there are some like processing time that has to happen. So after your application's complete, getting an admission decision back or getting your login information, meeting with someone if you have questions about anything before you schedule, and then getting a bill and being able to plan financially. So I would say, end of June, early July, maybe at the latest to have your application done, just so you have a couple of weeks for some planning and getting ready for the semester start if you're looking at fall. This just kind of walks through what those next steps are going to look like. So the first thing you'd have to do is create an application portal account. I think there's been some links shared in the chat over here, but you'll create that free account. It's with an email address and a password. Then you'll insert a graduate school application. When you get to that point, you're going to want to know what semester you want to apply to. You're going to want to fill the questions out in order in that application. You skip around, it kind of messes some stuff up. So you want to make sure you're filling it out in order because it populates the next questions. Just make sure that you're selecting the right semester of study. You say online if you want online, and that you are moving through in order. So when you get to the end, you'll hit submit, and then an admissions checklist is going to populate inside that application portal account. And that's where you're going to upload your transcripts and you'll upload a resume. Now, transcripts for purposes of the application can be unofficial. We can work with those. Up front, it helps speed up the admissions process and get you an admission decision faster, but it is a requirement that you submit an official transcript, typically within your first semester of starting your program at Michigan Tech. After those checklist items are complete, the system will see that, mark it as complete, and send it through the review process for us. Typically, we have admission decisions back. I usually say within 2 weeks, but sometimes it's within a few days. They're usually pretty quick about getting those admission decisions out. You'd get an email that says there's been an update to your account. It would prompt you to log into this application portal to view that admission decision. If you've been admitted to the program, you'd hear from me and we talk through all the next steps at that point. So how you get your login information, who your main contact person is, other resources for you as a new student, things about orientation, cost information. If you need to have a conversation, we can do that too. But in all of that, I'm kind of your main primary point of contact. So as the graduate admissions manager for the global campus, you can schedule an appointment with me. We can have a phone appointment. We can have a virtual appointment. If you have some real specific questions about your unique situation before applying or as you're applying, you get hung up on any steps, schedule an appointment with me. We can chat through all of that. If you're concerned about financing your degree, we can talk through all of the numbers and give you a better idea or run through some different scenarios to see what might be a good fit for you. So should be sharing a link to my calendar in the chat. Feel free to schedule a one-on-one for us. I'd be happy to have a conversation with you. And then, of course, if you have real specific questions about any of the information that we presented here today about the courses within the certificate, Jeff and Andrea are definitely subject matter experts and welcome those questions as well. So their contact information is shared here too. But with that, that kind of wraps up our session.